ball on the top of a, let's say, 8 meter ledge. It's going to be thrown straight up at 10 meters per second and allowed to fall all the way back down to the ground. Straight down, straight up, straight down. How long is it in the air? How long is it in the air? How do I find distance with what? Again, I don't understand the question. How do you find distance with what? How long is it in the air? Since it isn't straightforward. And how high up does it go? Those two things. Those are the two things I want to know. So this ball is actually thrown at a 90-degree angle straight up. This actually looks a little Halloween-y with the document camera light underneath. Oh well. So let's find out how long it goes. So when it's thrown straight up at 10 meters per second, we're going to again use our delta V equation equals A delta T to find out how long it takes for it to slow down. Now, VF minus V0 equals negative 9.8 times multiplied by time, whatever the time is. Okay, our final velocity is 0 again, so we have negative 10 equals negative 9.8 multiplied by delta time. And if we divide both sides by negative 9.8, we end up with a delta T of 1.02 seconds. That's how long it actually travels straight up. That's how long it travels straight up. But again, now that it has traveled up some, it's actually going to fall from there down. Okay, that's how far it's actually going to fall, not just this 8 meters right here. So we have this, so let's say delta T1 is 1.02 seconds. And let's see how high up it went. That's our delta Y equation, equals 1/2 A delta T squared. Okay, so our delta Y is equal to 1/2 negative 9.8 multiplied by our time squared. And if we punch all that stuff into our calculator, 0.5 times 9.8 times 1.02 squared, we end up with a vertical displacement of 5.098 meters. Quentin, I'll address that in a second. So we know that it went up 5.09 meters per second. So it was thrown very, very fast upwards, and it travels an additional 5.09 meters up. It is going to fall from that height the rest of the way down. So we're going to add this 8 meters to this 5 meters, and our total change in Y is equal to 13.098 meters. So we're going to do this calculation again, except using our total, our fall from the very, very top. So we have 13.098 equals 1/2 negative 9.8, which means this has to be negative 2, divided by, or multiplied by the time squared. If we divide both sides by 1/2 of negative 9.8, we can divide it by and we end up with a time squared equals 2.66 seconds squared, and now we just have to take the square root of both sides, and our delta time is equal to 1.63 seconds. That's how long it takes to fall from the height that it ascends to when we throw it straight up. Okay, so we have to add this to this to get our overall flight time. So our total time is 2.65 seconds. This plus this. There we go. So we solve for delta y and we solve for change in time. Let's get a quick close-up look at it. And let's see. Okay.